Page 42, illustration 44. Let me know how was yesterday's exam. Quick in the message box. Anyone crossing 100? Crossing 100? 90? 80? Okay. Okay, I'll ask you in the words which you understand. Out of 20 MCQs, how many of you got around 15 correct? Forget attempts. How many of you got around 15 correct? Out of 20 MCQs? One. Okay, few people. 10 MCQs out of 20 could manage. 40, yes, okay, perfect. 12 was also good. This Sunday, which exam do you have?
Mechanical properties of solids.
Which one?
Mechanical properties of solids.
And next Sunday?
Current electricity 2.
Next Sunday, current. There was a mistake, I think 2 mistakes in the questions and the options yesterday. I think today we will come across those questions. I think you can solve them. Okay, there were 2 answer mistakes. Now,
This sum was there in the exam.
what is it? Can you come again?
Yes, sir.
Question 44 was there in the exam.
Question 44 was there in the exam. Okay. You will get many questions which will come in the exam, which have come in the exam. Okay. Now, tell me, do you know how to solve illustration 44?
Yes, sir.
Yes.
Easy, direct. Anyone needs any help, let me know. Sure, everyone getting it? Today I want to do something in
Yes.
KVL. That is why. Turn the page. See illustration 45. See illustration 45. Tell me if you can manage that, or I will do it on the screen. Tell me. Page 43. Illustration 45. I have told you how to do this kind of problems. Remember, I have taught you. So we will use the same logic and we will start. Okay. So I will also do it on the screen. So they are saying, find the current flowing through the resistance R1. Means in which branch they want us to find the current, this one, correct? And they've also told us in the question that the resistance are equal to R1 equal to 10 ohm. So this is equal to 10 ohm. R2 equal to 20 ohm. So this is equal to 20 ohm. And R3 equal to 30 ohm. And R3 equal to 30 ohm. And the potentials of point 1, 2, and 3 are, this is 10 volt. This is 6 volt. And the last one is 5. So this is our circuit, correct? Now, can I say all 3 are sources? Can I say all 3 are voltage sources? That means, can I say the direction of current will be 1, 3 meeting at point O, correct? Therefore, if I apply KCL, something plus something will be equal to 0 because current entering is equal to current leaving. Current entering, maybe it will be I1 plus I2 plus I3 equal to current leaving will be 0. Agreed? If I apply KCL. Now tell me, what is I1? Let this be V0. Tell me, what is I1? I1 is the current in branch 1. Can I say V by R? But here, what will be V? It will be V0 minus 10 divided by R1 plus what will be I2? 6 minus 5. 6 minus 5 or 6 minus 0 only we can take. Which logic you want to do? Which logic you want to go? Can I say this is V0? We can apply V0 in all our equations and we'll keep V0 on one side. Can I do that logic? So if I do that logic, can I say I will get 6?
Both of both of
6 minus V0 by 20. Someone saying something? Kunal? Can plus.
Sir, R1 is also mentioned, no?
Come again?
R1 is also there in the question they have given, no?
I'll substitute. Correct. R1. I will like this. R1, R2, R3. I wanted to substitute, but I substituted. We'll do it. R1, R2, R3, all will substitute. Getting this equation, all of you? Remember, we have done
Yes.
similar kind of circuit. The logic remains the same, only the numbers change. Okay. Now, what is the easiest way to solve? Easiest way to solve is by taking LCM or by putting something on the other side. Tell me, which way do you want to go? LCM?
LCM, yeah.
Okay. So LCM of 10, I think I'll get disconnected 1 minute. LCM of 10, 20, and 30. Tell me, 60. LCM of 10, 20, and 30, 60. Any number below 60 possible? Not possible. Correct? So can I say 60 is our LCM? So can I say 10 into 6 is 60. 6 into V0 minus 10 plus 20 into 3 is 60. Therefore, 3 into 6 minus V0 plus 30 into 2 is 60. 5 minus V0 equal to 0. Okay, I think I logged off 1 minute. Continue, all of you continue. Still not happening 1 minute. Continue. So can I say 6 into V0 minus 10 plus 3 into 6 minus V0 plus 2 into 5 minus V0 equal to 0, because if I take this over here, it will become 0 anyway. So now 6 V0 minus 60 plus 18 minus 3 V0 plus 10 minus 2 V0 equal to 0. Getting this much? Now keep V0 terms on one side. 1, 2, 3. So 6 minus 3 minus 2 minus 5. I am left only with V naught. Okay, then minus 60 plus 18 plus 10. So 18 plus 10 is 28. 28 minus 60, I know it will be minus itself. So when I say it will be minus 32. Okay. Tell me, are you getting clear?
Yes, sir.
So what is V naught? 30. So we got the value for V naught. What is the question they have asked in the what is the parameter I have to find in the question? I have to find current through the branch R1. Means I have to find I1. Correct? Now I1 is what? V1 minus V naught by R1. So I1 will be 10 minus this by R1. So tell me, what will you get the answer? R1 is there. V naught we found. V1 we know. So tell me, what will be the current?
Sir. Sir. Sir.
10. Not 10. 4.2. Okay. Others? 2.2. Aniket, correct. Okay, correct. Sumitra, okay. Sharwari, okay. Others give the answer.
What is the question?
To find I1. Sakshi, it would be V naught minus 6 and V naught minus 5 if V naught had some potential and other would be ground. All three are voltage sources. So we should take that minus this and that minus V naught. We should always take V naught as the center. So voltage source comes the first priority. So that minus the center. For example, okay, for example, wait, you have to get I1 in this. For example, I'll tell you to come to one question. Tell me the answer of that. Same type of question. Where can I find it? 1 minute. We'll come back. Before that, see here, concept application exercise 3. Come to page number 53. In that concept application exercise 3, look at the first one. Tell me if you can solve it and tell me the answer. Anyway, 4 options are given. Try to start. Can you see something similar? Same it is. Can I say, can you see it is same? Check. But now, what mistake do you notice is, I will show you one other type of question. Turn the page. See question number 10. Next page. 55. Question number 10, page 55. Now give me the answer for this. Aniket, okay. Okay, I'm getting answer
Sir,
as
can
3
you show
volt
the
and 1
previous
volt.
slide? Previous slide. Sir, the one before it. Sir, first slide.
Same slide I just. Why are you getting two answers, 3 volt and 1 volt? What is the issue? Why are you getting 3 volt and 1 volt? Answer is A, 3 volt. Getting it? Answer is A. Should I do it on the screen? 3 volt.
Yes, sir.
Question is correct. Fine. Now we'll use only one logic. We'll not use dual logic. We'll use the same logic. Sumitra will use that same logic what we had done last class. Okay. Now in that last class, look at this. We have to find the potential over here. So can I say this also acts like a voltage source? This also acts like a voltage source, and this also acts like a voltage source. That means when this acts like a voltage source, current will go from here. That will be I1, and the current that goes from here will be I2. And current that goes from here will be I3. And we will always assume that the potential, the sources are greater than this, because ultimately this is not having its own source. It is just V0 in between. So if I apply that logic, then always the source will be greater. Therefore, every term, for example, here also it will become I1 plus I2 plus I3 equal to 0. Till here everyone was clear anyway. This is applying KCL. Now I will apply only one logic, that is this minus this by this minus this, and this minus this. We'll keep V0 first only if the other one is ground. That we have done last class. Remember, when something was ground, then it was V0 minus 0. So over here, if I apply that logic, so I1 will be 5 minus V0 by R1 plus 2 minus V0 by R2 plus 2 minus V0 by R3 equal to 0. Just check whether I have substituted R1, V1, V2, V3 properly. Just check the substitution whether I have done it properly. This is V1, this is V2, this is V3. R1, R2, R3 all are 1. Now in this case, I will get 5 minus V0 plus 2 minus V0 plus 2 minus V0 equal to 0. If you are using this uniform logic, getting this equation, all of you, now there is no confusion. Now, if I have 5 plus 2 plus 2, 5, 7, 9 minus 3 V0 equal to 0. 3 V0 equal to 9 or V0 equal to 3 volt. Answer will become A. Check. Now, the question I was getting is, when do we put V0 first? We can use anyhow, but if I want to keep a uniform logic for all of you not to get confused, then if any time I have a ground, okay, ground, that is earthing, that time it will become V0 minus this by R, because nothing can be lower than ground. Then it will be V0 minus this by 1. Apply that logic. Otherwise, if you mix and match, then you will get confused. So always keep this uniform logic going forward. Clear? Getting the answer 3 volt, all of you. Now, also, if you look at question number 12, that was the same question where the confusion was, and that was the same question where we had in the exam. Check.
Yes, sir.
Correct? Same question. What will be our answer? It will, current will be from where to where? It will be from A to B. Everyone got it how to do it? Should I do it again, or everyone has understood what is the answer? The answer, there was a mistake. So the question was from here. Okay. Clear?
Yes, sir.
Now, we will apply KVL and we'll solve some problems. Okay, my main intention in today's class are few KVL problems. I'm not telling you to solve the whole thing. Just we'll get the equations and we'll get the current in the branch and we'll stop. Solving 1 and 2 depends on the numbers, but I want you to know how the current goes. We have anyway done KVL, right? Now I'll show you the problems that come from the module. So I want all of you concentrate on each and every problem and try to get the loops. Before that, try to get the diagram properly for the flow of current. Yeah, that's it. Just WhatsApp me after the class. Okay? Now come to page number 49. All of you, page number 49.
Sir, which page?
Page number 49. In that, can you see illustration 52? Okay, just check that illustration 52. Page number 49, illustration 52. I want you to solve this problem. No, I want you to just get the current in each branch, and after that we will apply KVL. Okay. Now I want you to get the current in the branch as per what they have done in the module. Okay. Now everyone look at the module. Can you see A, B, C, D, E? Saw the diagram. Now in the question, they have not marked any current. Check. In the question, they have not marked any current. And if you look at the answer, you can see the current I1, I2, I3. In every branch, you can see one current and you can see one direction. My question to you is, can you draw this circuit as it is? Can you mark the current on your own with your logic? Can you compare and tell me if you're getting it? All the current in each branch. Because if you're not getting the current in each branch, then your KVL will be wrong. Okay, I'm not saying you do I1, I2, I3 itself. You will understand the logic, right? You can take anything as I1, anything as I2. Can you start and tell me whether you can manage KVL or can you manage the currents? Start. Illustration 52. Branch DE has a small mistake. Just check. Branch DE has a small mistake. But first you try to get the direction of the current and the current itself. There are only two voltage sources. I agree. But then what do? Either you can keep it as IA, even that you can do. Instead of I2, you can keep it as IA. If you don't want to get confused with number of current sources, can I say instead of I2, you can name it as IA? Okay, because actually, as per our KVL, there should be only two current because there are only two voltage sources. I agree. They have used I2, you can use IA. But I would like it if you use IA itself, because how many voltage sources are there? Only that many currents technically have to be there. How many voltage sources are there? Okay. Yes, Sharwari, that is the thing. This is how the questions can come, and this is how you are supposed to get the answer. Did you get the mistake in the branch DE? Or did anyone finish writing the current in each branch? Can anyone tell me finished, not finished? closed mesh is a loop. Closed mesh is a loop. A loop is a closed mesh with resistance. Anyone got the answer of the circuit? I'm not telling you to solve it. I'm just telling you to mark the currents. Don't apply KVL. Just mark the currents. Shall very done. Very good. Others? Perfect. Done. Did you find the mistake, Aniket? Everyone found the mistake in the current notations?
Yes, sir.
Correct. Correct. Because the other term will cancel. Chitra, correct. Don't continue. Just keep the current. Then you can do any analysis. Loop 1, loop 2, loop 3. The overall loop. That is fine. I just want you to get the currents. Malhar, very good. Malhar, how much did you get yesterday? How many, right?
Sir, in D, I2 will not be there.
How much?
In D, I2 will not be there. Accordingly, the equations will change. I didn't solve it. I just wrote the equations.
No, fine. I'm asking you yesterday in the exam, how much did you get?
Somewhere around 66 out of 100.
Okay. Devansh?
Around 60, 65.
Okay. Stop. Some of you are getting, some of you are not getting. Now, what problems we did, where somehow direct current is going I1, that is splitting into I1 and I2. But the questions that we are getting right now, we are forced to split. Now, if you look at the solution and if you do, and if you're doing it differently, it is perfectly fine. Because solution sometimes the notations are confusing and the answer also is wrong sometimes. You apply your own logic, you apply and go. So what I will do is, one problem, let us take a question, let us all do it together and let us go till the end. Can we do that? All of us will do it together. We'll apply
Yes,
KVL,
sir.
we'll find the current. Okay, we'll do the next question itself. Because next question was a NEET question last year. Next question is actually a NEET question last year. Very high level for NEET. But I guess you guys should be able to get it. Now what I want you guys to do is, draw the circuit, just the question. And I want you to do it on the screen. Means I'll do it on the screen. I want you to do it with me so that we have the same notations and the same answer. Illustration 53, copy the circuit. Illustration 53, copy the circuit. It is A, B, C, D, E, F. Okay, not O. Okay, this is the question. This is the question. Turn the page. Now see the solution what they have done. See the solution what they have done. Tell me, what is the first thing you notice in the solution what they have done? Check the solution and tell me what do you think they have done. How many voltage sources are there? Tell me. How many voltage sources are there in the question? I1, I2, I3, correct? 3 voltage sources. Now, if you look at the solution, tell me how many currents they have. Check.
2.
2.
Can I say I can do 3 currents? Yes or no? Will it be possible to solve with 3 currents and 2 loops or 3 loops, or should I keep 2 currents? And if I keep 2 currents, which are the 2 currents I should keep? Okay, shall we start now? Okay, you guys try. You guys try. Tell me if you're getting it. You can do it your own way, but try to keep as minimal current as possible. Correct. Hmm. Okay, good. Yeah, 2 loops are enough. Sure, very excellent, very good. Don't stop at the equations. Continue with the answer. Answers are direct. Okay, so continue with the answer also. Hmm. Okay. Hmm. Any one branch, if you get other 2 branches, you'll anyway get. You get other 2 branches, you'll anyway get. Hmm. So Mitra, tell me, are you getting it? If you're having problems in the current, as of now, look at the circuit as it is in the module. And look at the circuit and get the equations now. At least get the equations looking at the circuit. How to get the currents will eventually come to know. I'm not getting it. Look at the loops, look at the answer in the circuit and try to get KVL for each circuit. And get the answer. Okay, Rudra, very good. Malhar. Okay, perfect. Chitra, you don't need to look at that. You can do it your own. 30 volt, you can keep your own. You can take the current coming out of that. Then you'll have 3 currents and 3 equations. Then you have to take 3 loops. Inner loop, left loop, right loop, and the complete loop. You can do that also, Chitra. Sumitra, perfect answer. Very good. Aniket, correct. I have one question. Tell me, in 11th standard, when we were solving current electricity, have we done drift velocity for you or I have not done drift velocity? 11th standard, did we do drift velocity as a topic or we had not done it? We had done, remember 11th standard current electricity? Did we cover drift velocity, current density? Did we cover all those topics? Current
No,
density?
sir.
No, sir.
No?
No, sir.
Okay, remind me at around 8:30. I will cover that topic because in some of the questions you will need VD and you will need J, that is current density. Small topic. We'll do that and we'll come back to this. Okay, people getting it, people struggling. Okay, stop the struggle, stop the struggle. Stop the struggle. I'll show you one more loop. Okay. Aniket, okay, fine. Then we can solve it. Okay. That was 1:1 answer, Aniket. That is velocity of the electron, right? That was not drift velocity. I'll do one question more. That again try to get the current, again try to get the answer. See here what will happen is first question, second question, third question, some confusion. Ultimately the confusion will be clear and every circuit you will get it. Now see, all these questions actually not necessary to be solved in the module. You know that in the module the actual questions to be solved are JEE exercises. But we are doing all this because these build the basics of that. Now I'll give you one task. Okay, all of you stop. I'll give you one task, then I'll tell you one shortcut of JEE exam, and then I'll go to drift velocity. Okay? Can you do one task? All of you, forget everything. Illustration 55. This is your task. I'll give you 3 minutes. Okay? Sharvari, I'll show you. As and when the loops come, you will come to know. Okay? As and when the loops come, you will come to know retrospectively. I'm doing it so that you understand what mistakes you're making in the previous. Question number 55. Tell me if you're finding it easy or if you're finding it tough. Don't solve it now. Read the question, read the answer. Tell me if you're finding it easy or if you're finding it tough. Illustration 55. Okay, Aniket, good. Rahul, correct. Now, tell me whether you're finding this solution circuit easy or tough. Let's see what they have done in the solution. KVL is easy. I'm asking how they have done the current in the circuit. And easy or tough? Siddesh, very good. If you take that Chitra, then you have to take the other one correct. But usually what they do is the main voltage source, which is the higher voltage source, they take the main current coming out of that. Check. Here it is 4.5 and 3. Correct, Chitra? So what you're saying is also correct. But usually they take it from a larger source. That will be the main current and then next place. But your logic also is correct. If the voltage of the top voltage source was high. Did you get it, Chitra? Now, if you're noticing, my main intention of showing you these problems is, even though I have two voltage source, listen to me, tell me if you understand this statement. Even though I have two voltage source, they are converting it into only one current, that is I and I1. Got it? You're not getting I1 and I2. They are even planning to reduce. You can do by the old conventional way also of KVL. Take loop 1, take loop 2 and do it. What they are trying to do is they are trying to do it a little bit advanced in the circuit itself. Because if I do it advanced in the circuit, the calculation becomes very easy. Now just imagine, you know the current. Now look at the calculation part. Calculation part becomes very easy. Can I say calculation part is the least of our concern? Our only concern is how the current is flowing in the circuit. What is the current in each branch? Now, at least you should reach that level that if I know current in each branch, I can easily apply KVL and get the answer. Now your only concern should be what is the current in each branch in the question. Can I safely say that if I tell you current in each branch, you can do KVL on your own? There is no confusion in KVL. There is no confusion in doing KVL in any loop and getting the answer I1, I2, I3. Now the only confusion should be which loop or which branch will have which current. And if in your mind, if you feel that if I get that, then my answer is done. Easy. You can do by the long cut way also. Now tell me, they have shown one answer on page number 51. Tell me how many of you understood that diagram, I and I1. They have applied KVL and KCL. Reply yes or no. How many of you understood how did the current flow in each branch? Just reply yes or no. Aniket, okay, very good. Siddesh, excellent. Rahul, very good. Arpit, okay. Rudra, correct. No answer means I'm assuming yes. Okay. Don't zone out in current electricity. Be with me. Aniket, Rahul, Siddesh, Rudra, correct. Malhar, okay. Okay. Sharvari, Arpit, okay. Now I will, for people who have not understood, I'll just show you how, what is their thinking, okay? I'm telling you, you can do it in your own way, but I'm telling you what is their thinking, okay? 1 minute. Okay. See the loop. Can I start now? See here. Now look at the question. Okay, I'm telling you their thought process. People who have not understood the loop, I'm telling you what was their thought process in doing the current. Okay, find the current in figure A. Now find the current in figure A means what? I have to find what? Tell me. I. That means look at this. Can I say I am bothered with the screen is there or it went?
It's there.
It's there.
I got locked up. Now tell me if you understand their thought process. Okay. Now their thought process is, listen to this. One main current I goes from here. Okay, listen. One main current I is going from here. It will split and come back. It will come I only. Correct? Understood? Forget what else is there. I'm telling you their thought process. What they are thinking is there is one voltage source and there is a current which is going from here. Now the current which is going from here, it will split into, ultimately it will meet over here and ultimately it will come back. Therefore, current leaving my battery is I, current coming back also will be I. Correct? That is any loop. Now, doesn't matter what else is there in any sub loop. That is all secondary thing. I know that my current which goes from positive terminal will split, come in and come back as I itself, like Wheatstone network. Remember in Wheatstone network, we had like this one circuit and current I was in Wheatstone network. Can I say current I was leaving this? Can I say it split into I1, I2, IG? Finally, I only came back. Remember in Wheatstone. So similarly, what they are thinking is my current I is going, it is splitting into whatever, but coming back as I. So my main intention is what is my current I? Therefore, their thought process is I will let current I pass over here. And at this point, okay, I'm assuming, okay, at this point, I'm assuming, let current I1, because there is a node. Okay, now if I apply KCL to this node, if the current I was going, I can take IA also. If the current I1 was going, therefore tell me how much should this be? According to KCL, current entering the node should be equal to current
I
leaving
minus
the node.
I1.
So current entering the node is I. Therefore, current leaving the node also should be I. Therefore, what I should do is I minus I1. Now, whenever you think you have made a mistake or not made a mistake, the safest thing to do is apply KCL on that node. Now tell me, what is the total current entering the node? Can I say I? Should be equal to total current leaving the node. Now what is the total current leaving the node? Here it is I minus I1. Here it is I1. Therefore, can I say I1 plus I minus I1 is the total current leaving the node? Therefore, can I say I? Therefore, can I say I have written proper? Therefore, that I splits into I1. Remaining current is I minus I1. They just are bothered about I. So if I consider this as my primary source, here it is I minus I1. Here it is I1. Tell me at this point if they meet and if they come down. Tell me what is the total current?
I.
Correct?
again.
Because it is I minus I1 plus I1. Therefore, can I say the total current coming back is I? So can I say they completely ignored this upper loop because they were concentrating on this voltage source? But can I say it satisfies KCL? Can I say it satisfies KCL? Now did you understand what was their thought process? Now, Chitra, what you're saying is, if I consider this as my main loop, you can consider that also as your main loop. Here it will split. Understood? But usually when you're thinking which one should be your main loop and which one should be your main current, your power source which is having higher value should be your primary. That means from here I should come out. Okay, that is their thought process. Understood now? Everyone, Sharwari, did you understand now? Aniket?
Yes, sir.
No, it's not required. Only I is required. Main current. Okay. Now, last one of this type. Again, don't do it. Don't do KVL. Next question, illustration 56. Tell me if you have understood the circuit and just see what they have done with KVL and tell me if you can do it. Don't do it. Tell me if you can do it. Read it and tell me. Again, illustration 56, how the current flows. Check. The current direction is given in the circuit itself. Means they have given the diagram, and in the diagram, the direction of current, everything is given for you. So that means you don't have to put current in each branch. What you have to do is you have to look at the solution, check whether if you apply KVL to both the loops, are you getting the same answer? And then are you doing it? Luckily for you, they have given the current in each branch. You just have to apply KVL. But before applying KVL, just make sure that every branch has a current with it. Does every branch have a current, or do you know what is the current in every branch? Yes, then you apply KVL and tell me whether you can manage. Just check.
Sir, can you explain this one?
You got the diagram?
Sir, I'm just confused with the direction of I1 and I2.
Yes,
They
sir.
have,
Same
they
here.
have given the direction in the circuit. We don't have to do it. The circuit as it is given in the question.
Sir, but how did they get that I1 and I2? How did they get
Sir, in
I1 and
SR branch, the direction should be opposite, no?
Getting very blurred. Someone is. How did they get I1 and I2? I will show. Someone else is saying something.
Yeah, sir, in SR branch, the current I2 should be opposite direction. No?
That according to our logic, it is correct. But what they have given, you have to satisfy that. Even I know that the current should go from positive to negative. They have given something else, correct? They have given some other direction. But I have to go along with the direction what they have given. Okay. Do you understand? I know that if I start to do the circuit, the current should go from positive to negative. But they have not given that. They have given some other direction. I have to follow that direction that they have given in the circuit. You
Sir,
understand?
even the direction is opposite, so sign will be positive. No?
Sign will be positive. That depends on KVL. When we do KVL, we have to see whether our direction is opposite to that of the direction of the circuit of the current that they have given in the diagram. Then the sign will be positive if we go against their direction. Because in this question, what they have done is they have given the direction of current. So if our direction is opposite to their direction, what they have given in the circuit, then you have to take positive. And if our direction is along their direction, then you have to take negative. Because if we go to apply I1 and I2, we'll get exact opposite. Do you agree? Because I1 will
Yes,
come like
sir.
this, I2 will come like this, and I1 and I2. But they have given their own directions. You have to follow that. I'll show you one more where we have to follow their direction only, even though we know that the direction is wrong, and we'll have to get the answer. And usually that answer of current will be negative. Okay, that answer of current will be negative. Now tell me, if their direction of current is given in the circuit, can we apply KVL? Easy. Following their direction of current. We don't have to break our head finding out the direction of current in each branch that they have given for us. Okay, for example, have we done this? Now see this. This is the question they have given in the exam. Okay. Okay. This is actually bit set. This is the question that they have given in the exam. Now look at I3 and look at I1 and I2. Now in this particular case, they have given I3, they have given I1, they have given I2. Means I don't have to apply the brain. They themselves have marked I3, I1 and I2. That means I just have to continue what they have given. Even though I know that I2 will come here I3 is there, here I1 is there. I don't have to apply my logic. I have to apply the logic that they have given in the diagram. And usually when they give such a logic which is not satisfying KVL, we usually get a negative answer for current. Okay. Now tell me, looking at the circuit, can you say this is my equation 1? Tell me, did you understand this?
Yes, sir.
Yes.
Okay. Now tell me, mark the direction of currents. Can I say this will be I1 according to them? Can I say this will be I2 according to them? Therefore, can I say, I told you first itself, each branch can have only one current and one direction. So can I say this branch completely is I1? This branch completely is I3. This branch completely is I2. These two I don't need anyway because I'm not going to solve. Can I say now if I apply KVL, I will get the answer? But usually in such cases, our answer will be negative. Usually, whenever we see that the direction of current is violating the actual law, the current will be negative. So what happens is in the exam, when such question comes, automatically this and this answer is eliminated because usually the answer is negative. So students, to save time, they know that something is wrong because this direction is not correct. So what they do is they eliminate this and the confusion should be only between this and this. Can you solve and tell me what will be the answer? Can you apply KVL in each loop and tell me what will be the answer? Start. I will not, this is not there in the question. I'm erasing this. Only this much is there in the question. This is the clue I am giving you. I3 is equal to I1 plus I2 is the clue I am giving. Start. Answer is on your screen also. If you are struggling, just check.
Sir, here they took I3 as I1 plus I2.
And we write what?
They in here they took I3 as I1 plus I2. Okay, sir.
Here they have taken I3 is equal to I1 plus I2. That even I gave you the clue, right? Over here, check. Without that, it becomes tough. I go to the next one. Or any problem in this one, I'll explain. Let me know. I've got most of you replying that you're getting it. Okay. Getting somewhat, getting it somewhat. How to get the current I1, I2.
Yes, sir.
Yes, sir.
Aniket. Yeah, I'll show you one magic. Want to see the magic, Aniket? Here it is. Again, not charging. Now, see concept application exercise 3. Try to solve this. This is actually a 1 minute question. Okay, this is a 1 minute question. Now I want you to at least try to get some current in the circuit. Then we'll discuss. Page number 56. Page number 56. Page number 56. All of you, okay? Now just think of it as a new problem and just try to solve question number 15. Look at the circuit. Everything is given. Try to get it. Try to put the current I1, I2, whatever, and try to get the answer. This is the answer you're supposed to get. I've written the answer on the screen. Just check whether you will also get the same. Can anyone tell me what will be the current on branch R2? Anyone? Current on the R2 branch? Anyone? Anyone?
I2 minus I1.
I2 minus I1. Okay. Why not I1 minus I2? Why not I1
Because-
minus I2?
And the direction should be opposite in the left hand
Right.
side.
If you use the direction opposite, I1 minus I2 also can come. Check.
Yeah, it will be in the left hand side direction.
Rahul, if you take I3, then you'll have 3 unknowns and 2 equations. You have to get the middle branch of R2 in terms of I1 and I2 itself. Okay. Otherwise, if you take I3, okay. No, it is not I1 plus I2, Rahul. I3 will not be I1 plus I2. Middle branch is not I1 plus I2. Correct?
Sir, it will be only I2.
Tell me, what is it?
Sir, middle branch will be only I2.
Can someone repeat what he's saying? His voice is blurred.
Sir is saying middle branch is only I2.
What is he saying? What is he saying?
Middle branch is only I2.
Middle branch is only I2. No. Middle branch is not only I2. Apply KCL. Apply KCL. Tell me which. Okay. Okay, listen. Tell me, you want to take the current like this, or you want to take the current like this? What will be the answer? Tell me which direction you want to go, right or left? Can I say if I1 is going here? Just once look at the screen. Everyone look at the screen. If I1 is going here, okay. Now just think, okay. Just think. If I do over here I1 minus I2, okay. I1 minus I2. Okay, I'm assuming I take here I1 minus I2. Now at this point, apply KCL and tell me, does it satisfy? Just try. Does it satisfy? Now tell me, what is the total current entering this point? Can I say total current entering this point is I2 plus I1 minus I2? How do I get it? The total current entering is I2 plus I1 minus I2. Therefore, can I say plus I2 and minus I2 cancels? Therefore, total current leaving also should be I1. Therefore, can I say total current leaving is I1? Therefore, can I say at this point, KCL is satisfied? If I take I1 minus I2, did you understand how I took I1 minus I2?
Yes, sir.
You can do permutation combination. You can take I2 minus I1 also. Now, if I take over here I2 minus I1 with the same logic, tell me, will my KCL be satisfied? If I take I2 minus I1, will my KCL be satisfied? Let us try. So it will be I2 minus I1 plus I2, the current entering the node. Therefore, I2 plus I2, 2I2 minus I1 should be leaving. It is not leaving. Therefore, I cannot take I2 minus I1. I have to take I1 minus I2. And for I1 minus I2, this node is perfectly satisfying. Whatever is the question of I1 and I2. Now, can I say I have got current in each branch? Now, can I apply KVL and get the answer? The answer is 1.6 and 1.8 respectively. Tell me if you're getting it or not. 1.6 and 1.8 respectively. Tell me if you guys are getting it. I'm telling you, use KCL at every node and find out whether you're getting it. Again, if you're confused whether it is I1 minus I2 or I2 minus I1, apply KCL. If for both KCL is applicable, very good, then both are right. It should not be possible, but yes, it will be right. If you feel your answer is right, and if KCL also is right, that means your answer is right. KVL, it depends on you, which loop you take. But over here, KVL is not important. What is important is to get the current in each branch. To get the current in each branch. Easy. Understood why I1 minus I2 now. Now, if I say if this branch is I1 minus I2 with this direction, applying KVL is nothing great. I can easily get the answer 1.6 and 1.8. Okay, check. Okay, you need some time to do it. Do it. 1.6 and 1.8 will be our answer.
Sir, can you show the solution?
We'll solve it, you're saying?
Solution, sir.
Solution means I should solve it now that way.
Yeah, sir.
I'll solve it. So, in the following circuit, R1 is how much? E1 is 4. R1 is 2. Then E2 is 6. R2 is 2. R3 is 4. Find the current I1. Find the current I1. Okay. Now let me take this loop 1. Okay. I'll take this as my loop 1. Understood which loop? The upper loop. I will take it as my loop 1. And if I apply KVL to this loop, I will get minus 2I1 minus 2, correct? Minus 2I1. You want me to label A, B, C, D, E, or we can go directly? Understood how?
Yes.
Minus 2I1 minus 2I1 minus I2 plus 4 equal to 0. Everyone getting this as your first equation? Okay, now apply the same KVL to loop 2. Start. Apply the same KVL to loop 2. Siddesh, correct. But try to get it in decimal. Try to get it in decimal. Tell me what your answer is in decimal. Minus 4I2, correct? Minus 4I2. Then over here it will become plus 2 into I1 minus I2 plus 6 will be equal to 0. Or you can take this, this. Getting this answer? Getting this equation, all of you? As your second equation?
Yeah, sir.
Yes,
Now,
sir.
if you solve these two, can you get, or should I continue? Now getting it? Siddesh, your answer is correct, but you have given me the answer in fraction, you have to give me the answer in decimal. Otherwise, your answer is correct. Siddesh, okay?
Sir, we have to equate these two solutions, no? We have to equate these two solutions, right?
We have to equate these two solutions in the sense we'll have to get one equation. Solve the two simultaneous equations, you will get the answer. You don't need to equate. You can equate also, actually, but it's two simultaneous. Nothing great in this. Okay. Then we go to the next step. See, tell me whether we have done question number 19 on page 56, a similar kind. Or the same, have we done the same one or a similar one? Check. Question number 19. Page number 56.
So I've done a similar type.
Similar, not the same one, right?
No, sir.
Start. Then start and give me the answer. Question number 19. Start and give me the answer. In this case, ground is there. That means the current flows to the ground. So you have to apply that logic. I think we have done the same one, but okay, anyway, start.
Yeah, so we have done the same one. I've checked also.
Yes, sir.
We have done the same one only, right?
Yes, I3 is coming 4.5.
Can you solve question number 18? Last one of this type, okay? Then we'll go to drift velocity. Just try to solve question number 18. Now see here I3 is going down. It will split into I1 and I2. So you can take I1 and I2 is I3. We have done a similar problem. Check question number 18. And try to apply KVL in that and give me the answer. Question number 18. Start. This is a very easy question. What they have asked? Find the current I3. Answer will be minus 5/6 I3. You will get I1 as minus 1/2. You will get I2 as minus 1/3. And you will get I3 as minus 5/6. Tell me if you guys are getting it, yes or no. I have given the answer. I3 is minus 5 by 6. If you are getting this, then you will get all kind of problems like this. Okay. Okay, just confirm. I mean, Sumitra, very good. Aniket, very good. Others, tell me, are you getting it? Devansh, excellent. Okay, Malhar, very good. Devansh, okay. Rudra, let me know if you're getting it. Siddesh, let me know if you're getting it. Okay. Rahul, correct. Okay, now stop. Stop. Now I'll do a small topic of drift velocity and current density. Okay, now listen. In current electricity, this actually part was omitted from your HSC, so we had not done. But I'll tell you the basics. Okay. Now write down the side heading current density in your notebook. Okay. Very simple concept. Just write down side heading current density in your notebook. And remember, what is population density actually? Population density is population over a given area. Correct. Similarly, what is current density? The amount of current over a given area is called as current density. Therefore, listen to this. Current density is denoted by capital letter J, and the formula for current density is current over a particular area. The formula for current density is current over a particular area. Now, current is given as ampere. Area is given as meter square. Therefore, the unit of current density is ampere per meter square. So make a note of this first. Made a note in your notebook. Now give me the dimensions. Quick. Ampere per meter square. Give me the dimensions. Give me the dimensions of current density. Ampere means A1, meter square means L power minus 2. L minus 2 A1. Got it? Okay. Now there is something called as drift velocity. Now remember one thing. Don't write this. Listen. Drift velocity unit will be meter per second because ultimately it is velocity. Now, what is the meaning of drift velocity? Is electrons always go in the direction opposite to that of the applied electric field. Always remember, electrons always travel in the direction opposite to that of the applied electric field with the velocity called as drift velocity. Electrons always oppose the electric field and they go against that. That means if everything is going in one direction in a circuit, electrons go in the opposite direction with the velocity called as drift velocity. Therefore, whenever drift velocity is given in the question, you should understand that they're talking about electrons. Number one, that means you will know mass of an electron, you will know charge of an electron indirectly, because they will not say it is electron. They will just mention drift velocity. You should understand that drift velocity, they are talking about electron itself. Okay. Now see the textbook definition of drift velocity. The electrons under the action of applied electric field drift with the speed Vt, that is drift velocity. Actually, this is not the notation. Notation is this: small letter v suffix small letter d in the direction opposite to that of the applied electric field, and the velocity with which they go against the direction of electric field is called as drift velocity, and the unit of drift velocity will be the same as velocity, which will be meter per second. Therefore, make a note of the definition, make a note of the unit, and please make a note that it is specifically for electrons itself. It is specifically for electrons itself. Start. The electrons under the action of applied electric field drift with the speed in the direction opposite to that of the applied electric field. This is called as drift velocity. Okay. Now, the formula for drift velocity in terms of current density is on the screen. Now, this formula is a very simple formula, but many times you get problems directly based on this formula. Okay. So please make a note. Drift velocity is current density upon NE. I hope what you know what is the value for NE. Tell me what is NE.
Q.
Do you know this? Q. So the formula for drift velocity is J by NE, or can I write it is I by ANE, because J is equal to I by A. Therefore, can I say the same formula can be written as I by A and E. Therefore, make a note of drift velocity in terms of current density. Make a note. So the formula for drift velocity VD in terms of current density. Start. Basic questions. Chitra, any convention circuit diagram? Yes, correct. Chitra, you can say that. Start solving. You know the formula. Now start solving. Check if they are getting it. Don't solve the complete thing. Tell me if you're getting it till here, it is fine. I want you to know this formula, J becomes I by A, this formula. So you should know this formula, and from that formula, it becomes this, that you should know. Otherwise, it is direct. Clear? Easy. So there is one formula for drift velocity, and directly for J, it is this question. Okay, directly for J. Direct question. Start. Okay. Start. Now, using similar logic, done it. Now you see how NCERT, NEET, JEE ask you this question. Okay, these are board questions. Now, if you want a little high level, it's not high level; it's the same formula. But okay, come to page number 71. Come to page number 71 of your module. Question number 18. Start. Tell me if your answer is this. These are the options actually. Okay. Others check. I'm getting answers between A and B. Well, I did not understand the question. That is number of charge carrier, number of electrons, Rahul. Number N. It means
Okay, sir.
N. Okay. Now on the same page, we'll do some basic questions. Okay. On this, we'll complete the basic questions. Start with 17. Tell me if you get it. Tell me what logic will you apply for question number 17. Page number 71. Page number 71, question number 17. What logic will you apply? So listen, the potential difference applied to an X-ray tube is 5 kilovolt and the current passing through it is 3.2 milliampere. Milliampere means into 10 power minus 3 ampere. Find the number of electrons striking the target per second. Striking the target per second. That means they have given T also as 1 second. So tell me, what can I find out first? What can I find out first. Think about it. One value is dummy value. I want to find number of electrons. Think.
We will get the charge.
Hmm?
We will get Q.
We will get Q. Tell me, how do I get Q first?
I is equal to Q by T. And
Or
T
Q
is
equal
1.
to IT. Therefore, tell me, what is the charge you are getting?
3.2 into 10 raised to minus 3.
Now, I also know Q is equal to NE. I also know Q is equal to NE. Now, do I know the value for Q? Yes. Do I know the value for E? Yes. 1.6 into 10 power minus 19. Can I get the value for number of electrons? Yes. So can I say in this whole question, V was not required at all? In this whole question, V was not required at all. I use the two basic formulae for charge. From 11th standard, I use the two basic formulae for charge. Q equal to IT and Q is equal to NE. Now, can you solve and tell me what will be the answer? The clue is on the screen. Two into 10 power 16. 2 into 10 power 16, I think, is the right answer. 2 into 10 power 16 is the right answer because 16 twos are over here. 3.2. That means 1.6 twos are. Tell me, are you getting this answer? 2 into 10 power 16.
Yes.
See, if you look at the question as it is, looks very complicated. Potential difference and just that, but we are applying only two basic formula and we're getting the answer. Easy. All of you, please confirm that you're getting this answer. Okay. On the page. Start with 25. Last 2 to 3 problems and then we'll stop. Start with question number 25. The clue is again, resistivity rho is equal to RA by L. So try using the same formula and get the answer for the 25th one. Page number 72, Satish. Page number 72. Answer is given on the screen. Tell me if you're getting this. Length is given, area will be square. Resistivity is given, length is given, area can be found by length square. You have to find R, and the value of R is given here. Check whether you're getting the answer as 10 power minus 6. All of you. Not 2 into 10 power minus 6. Answer is only 10 power minus 6. Tell me. Yes? Okay. Last question for today. Question number 26. Same formula, same logic. Start. answer is this. 2 into 10 power minus 7. Okay. With that, we'll stop for today. Your homework is just to keep practicing the problems that we did today. Just keep practicing and submit the PDF. Whatever we did today, just submit it neatly. Next week, we will continue from current electricity 1 itself. And in your main exam, that is current electricity 2. Again, from the beginning till whatever I have completed. And the combined exam, again, from the beginning till whatever I have completed. Understanding? So for the
Yes.
next, not this Sunday, the next Sunday, current electricity 2, from the beginning till that day, whatever is taught. For the combined exam also, from the beginning till that day, what is taught. Okay, we'll keep doing current electricity. Yeah. Okay. So thank you all of you. I'll see you next week. Bye-bye.
Thank you, sir. Bye.
Thank you, sir. Bye, sir. Thank you, sir.
Bye, sir. Thank you, sir.
Hmm?